Yes, take your attendance first. Yes, so let's we go to the lessons today. Okay, so let's be. Okay, put the code on the WhatsApp. You can check from there. Okay, so yeah, we are halfway of discussing the examples of circular motion. So that day we successfully discussed about this is 2 days ago, and discussed about the most complex circular motion, the vertical circular motion. Anything you circulate vertically, the tension going to vary from the bottom to the top, and it become maximum at the bottom and become minimum at the top. Okay, then we work out the what do you call the minimum speed and the maximum speed. Okay, a minimum speed, which point do you consider to find the minimum speed? Where's the critical point to calculate the minimum speed? Top or bottom? Should be the top. Okay, because if you circulate it with a very little speed, the most critical point most likely you can't reach is the top. So top is the point to consider to find the V minimum. V maximum, we consider the bottom. V maximum, we consider the bottom, because when it comes down, that's the moment where the tension become maximum. Tension going to limit the speed. So if you whirl it with a very high speed, it most likely going to break at which point? At the bottom. Okay. Okay, now after this, the other system is going to be a little easier than what we learned so far. Okay. The first body, the tension contribute to the centripetal force. For the second system, the tension and weight contribute to the centripetal force. Okay. Now we go to the third example. Okay, third example. So third example is car moving around a curve. The centripetal force. Okay, car moving around a curve. So we go like this. Okay, this is the diagram. So this is a plane view from the top, like a satellite. Okay, view from like a satellite. So view from the top. A car is making a movement in a curvature. Okay. So first, we're going to investigate this, and we want to find what is equals to the centripetal force. What equals to the centripetal force for this system? Okay. So the car, what are the force acting on the car? What force acting on the car when it makes a curvature? So there is a force acting into the page. The one acting into the page. Of course, the weight. The weight acting into the page. Very difficult for me to show that force. It's into the page. Out of the page, what force? Out of the page, coming out from this picture is what? It's a normal reaction, right? It's a normal reaction. Okay. Any other force acting on the car? There is one force acting towards the center. What force acting towards the center? You can imagine there is one force acting towards the center when the car makes a turning. Okay. What force acting towards the center? Genuine, what do you think?
Centripetal force.
Okay, so centripetal force. Okay, so centripetal force is a type of net force. It's a net force. So let's say I ask you a pendulum is swinging just now, the earlier system swinging vertically. If I ask you to draw the free body diagram for this pendulum at the bottom, so you draw the tension up, you draw the weight down. Do you put another arrow at up and you say is the centripetal force, or do you put arrow up, you say is the net force? Can we represent net force in the vector diagram? I mean, in the free body diagram. Do you put an arrow saying is an arrow that there is a net force upwards in a free body diagram? Okay, you won't put a net force direction. You won't put that arrow. We just only show what are the forces acting on the system. So in this case, tension mg is the one properly you need to state. You can't state the net force as an arrow. Okay, net force cannot represent in a vector diagram. So here in this, of course, the centripetal force acting towards center, that's the net force. But what force providing it? But in this case, you see, the tension is the net force. The tension is the centripetal force. There is another force contributing to the centripetal force. So what force acting in this car towards the center, which is going to contribute to the centripetal force? What type of force? Okay, so Janta, what do you think?
I'm not sure.
Not sure. Imagine a car making a curvature. There is one force acting towards the center. Anyone can try, give a try. Praveen?
Yes, sir.
Any idea?
Not sure, sir.
Can't imagine, eh? Okay, give a try. Ashley?
Can it be friction?
Very good. Friction. So friction, yes. So friction is the answer. The friction between the car tire and the road is the one acting towards the center. Okay. The friction between the car tire and the road is acting towards the center because the car want to make a turning. If there is no friction between the car tire and the friction, like ice skate, skating on the ice, of course there is no friction. Although you like to make a turning, okay, let's say, but you are not you never wear the skating shoe, but the normal shoe, let's say you are just sliding. Although you try to make a turning, you can't make a turning because you don't have friction between your shoe and the ice, so you go straight. So which force going to act as a centripetal force to you? You want to make a turning in ice, not in ice, in a road, is the friction. The friction is acting towards the center. Okay, good, Ashley. So friction acting towards the center, weight acting into the page. I can't show you that. Normal force acting out of the page. Okay, of course, the forward force is the thrust. You have the thrust force acting forward. And of course, at the back also you have some sort of another type of drag force. Drag force, your air resistance, and also there is a friction at the back too. Drag force, yeah. But there is a friction acting towards the center. But whatever force acting 90 degrees to the center of the circle, it's pointless for us for our discussion. Because any force 90 degrees to the center of the circle, if you resolve it, it won't contribute to the centripetal force. At the same time, it's not opposing it. So in this case, I think pointless we discuss about the thrust, pointless we discuss about the drag, pointless we discuss about the weight, pointless we discuss about the normal force. All of them are 90 degrees towards the center of the circle. Correct, right? Weight, you see weight going into the center of the weight is going into the road. So you're going into the road and you check the center of the circle is 90 degree insideward. So weight doesn't contribute anything. Okay, yeah. So now let's we go back. Okay, get me what equals to FC for this system. So what equals to FC? So should be the friction, right? The only force acting is the friction. So friction is the centripetal force to this system. Okay, friction is the centripetal force of the system. Okay, so let's investigate further about this. Okay, a car move on a curvature, the friction between the tire and the road contribute to the centripetal force. Okay, so let's investigate further. Okay. Okay, good. Just now it doesn't work. Okay. All jam. Okay, guys. Okay, let's see. So you are driving. Okay. Let's say a new you have car and you bought a new tire. You just fixed a new tire on the car. Okay. The car tire can withstand a friction of, let's say, 2000 Newton. The car can withstand a friction of 2000 Newton, and you drive through a curvature which makes a radius of, let's say, makes a radius of 20 meter. The curvature of the road is as a radius of 20 meter. Okay. Okay, it's not a complete circle. The curvature is a part of a circle. Still, centripetal force is required. Okay, now the question is, your tire is new. New tire can withstand a 2000 Newton of friction. Okay, now tell me, what is the? Of course, you will have a speed limit, right? You have a speed limit, right? What is the fastest you can go without skidding, right? Okay, the speed limit is V max or V minimum. It's going to be the V max, right? V max. So you have a certain maximum speed you can go without skidding. Okay, let's work out. What is the Vmax for this system? You have a friction of 2000 Newton, radius of 20 meter. So let's say you drive with the speed of, you are driving with the speed of 10 meter per second. You are driving with the speed of 10 meter per second. So what is the centripetal force? What is the friction going to act towards the center? What is the friction going to be between the tire and the road? So friction is the centripetal force. Okay, check the centripetal force should be how much. Let's say the car, I need to give the car mass. Let's say car mass is 1500 kilogram. Okay, 1500 kilogram. So 1500, the speed you are moving is 10 squared. The radius is 20 meter. So how much you get about friction? Okay, anybody? Come on, please calculate for me. I don't have calculator with me. 1500 times 10 squared divided by 20. So it's 7,500. Is it? Okay. You got what? You get 7,500.
Yes, sir.
7,500 Newton. Okay. So you if you drove with 10 meter per second, the centripetal force required is 7,500 Newton. Okay. But your car tire only capable to produce a friction of 200 Newton. What will happen to the car? Can he go around the curvature, or start to skid? Start to skid because he can't stay in the circular path, because friction only can afford to provide 2000 Newton, but centripetal force is 7,500. So who's going to provide the centripetal force? The friction. But friction can't afford to give 7,500. It only can give up to 2000 Newton. So the car start to skid. Okay, now your friend having this tire, this type of car, and radius is 20 meter, you want to pass this curvature. Now you need to help him. What is the maximum speed he can go through this curvature? You come and give a try. What is the maximum speed you should go this curvature? If it exceeds that speed, you're going to skid. So how do you calculate? So the friction, the maximum friction, the maximum friction should be equals to mv max, the maximum speed. This is your working. Okay. So from here, we can work out the Vmax. Okay, find the Vmax. Just rearrange, you can get the Vmax. So in this case, friction max is 2000 Newton, and the R was 20 meter, and mass is how much? mass is 1500, and friction times R over M square root. So this is the speed. It can go without skidding in this curvature. Okay. So anyone already get for 80 over 3, 80 over 3, right? Anybody? 2000 times 20 divided by 1500 square root. What is the answer? Calculate for me. Anyone?
5.16.
Okay, 5.16. Thanks, Ashley. Okay, 5.16 meter per second. Okay. Yes, good. So for this curvature, if this, I think that in reality that the friction of the tire should be a lot, but I give a number as 2000 Newton. So for this person, for this type of tire, for this type of car, no choice. You only can move this 5.16 meter per second or lower. Friction can afford to contribute to the centripetal force. If greater than that, the car start to skid. It will start to skid. Act of nature. Why the car start to skid? Because the nature tried to increase the radius. If it increase the radius, what happened? If it increase the radius, the centripetal force is going to drop. So until it fall to 2000, it stays that movement. Start to skid to increase the radius. Act of nature. Okay. Okay. So in exam, they will tell you. They will ask you. Okay, a car move in a curvature. Okay, what is the V max? So you should remember that. When the V is maximum, the friction is maximum. So the friction maximum is dependent to the condition of the tire. Okay, you believe, right? You remember, right? When a new tire, maybe nearby your house, there might be a curvature you used to go around every time. So with the new tire, you can go faster. You will feel like safe. You never skid. But maybe after 2 years later, use the same tire, you go. What happened? The tire already exhausted. The friction is not as good as last time. You can't go to that speed anymore because friction, the maximum friction has dropped. So your Vmax also will drop. You can't go faster. So yeah, this is how it works. This is the third system. So what type of force contribute to the centripetal force in this system? What type of force contribute to the centripetal force in this system? The friction between the tire and the road. Okay, that's the answer. The friction between the tire and the road contribute to the centripetal force. Okay, any questions, guys? Any part you don't understand? So hope you understand. Okay, I think this for me the whiteboard giving trouble now. Okay, so that's about this system. Friction contribute to the centripetal force. When V max, then friction become maximum. Okay, friction become maximum. Okay, any questions? No questions. Okay, so we go to the next one. Okay, I don't think so. As I said, not the system is not as demanding as this one. Vertical, quite complex. Okay, so next we go to the next one. Next one is something different. Okay, fifth example is a plane. Okay, an airplane turning in the air. The the centripetal force is given by the lift provided by its banked wing. Okay, this is the description I give you. Okay, a plane makes a turning in the air at a constant height. Okay, a constant height from the ground. Let's say this is the ground. From the ground, it makes a turning. Of course, it makes a turning in a circular path at a constant height from the ground. The height doesn't change. Okay. So the question now, as usual, to investigate this system, and we want to get, of course, the formula what equals to mv squared over r for this plane. What are the forces acting on this plane? The plane is going into the page, into the page. what are the forces acting on the plane? If you know the forces, then whatever force acting towards the center minus whatever force opposing going out should be the centripetal force. Okay, now I give you 1 minute. Come on, think what are the forces acting? Imagine a plane is moving towards into the page. Like remember, it's moving into the page. It's a little tilted. Okay, maybe I can draw the diagram again. This is the plane. The plane is here. Okay, so like this. It's going into the page. It's going into the page. Okay, so what are the forces acting on this plane? What force acting? Of course, weight acting down. Mg is acting downwards. The weight of the plane acting down. What else? There is one force acting like this. This is called lifting force. I put L symbol. It's actually lifting force. Okay, the plane when travel, the what you call the wing going to make it to lift up. Lift up. Okay, what principle is that? I think I don't know whether you learn in your O levels or not. Heard of Bernoulli's principle? Anyone? Bernoulli's principle. Bernoulli's principle. Okay, I think O levels. Do you learn Bernoulli's principle? Anybody? Do you learn Bernoulli's principle? I don't think so. You never learn Bernoulli's principle. If you want, you go to the YouTube. You just type in Bernoulli's principle. They'll explain how a lift force is created for a plane. Okay, so plane, because the speed of air traveling on top of the wing and the bottom is different, it creates a force upwards. It's called lifting force. So I don't want to go in depth about that, Bernoulli's principle. So, but you should know the plane will have a lifting force perpendicular, the 90 degrees to the wing, 90 degrees to the wing. So that's a lifting force upwards. Okay, let's say in this case, because it's tilted vertically, let's say I put an angle. Vertically, the angle is theta. Okay, imagine it's theta vertically. Okay, so weight acting down, lifting force acting diagonally, perpendicular to the wing, because wing also already a little tilted, so the lifting force will be tilted to the side. Okay, let's say it makes an angle of theta from vertical. Okay, any other force acting? So one of your friends said is upthrust. Okay, upthrust. Yeah, of course we have upthrust, but in the air, upthrust is neglected, very small, very small. Okay, good. So we have upthrust, but it's very small, not really considered. Any other forces? There are another two forces acting. Air resistance. Yes, good. Air resistance. Very good. One of your friends said is air resistance. Air resistance into the page or out of the page? Air resistance, because the plane is going into the page, so the air resistance should be out of the page. So air resistance coming out, out of the page is actually make I can say it's make a 90 degrees to the center of the circle. So as I say, any force acting 90 degrees to the center of the circle, it doesn't contribute to the centripetal force. At the same time, it doesn't oppose the centripetal force. Although the air resistance acting, but we not really look into it. There is another one force acting into the page. What force? Of course, the thrust. The thrust of the engine. The thrust, the engine thrust acting towards the forward. Forward. Okay. Yeah, so these are the forces. The thrust also make 90 degrees, so that's also we don't consider. Okay, the only force you need to consider is, of course, the lifting force. Mg, check. Okay, tell me, what equals to centripetal force for this system? Okay, this is the first time the force has been tilted. Okay, it never act perfectly towards the center, but beginning of the topic, I think I think the second class, if I'm not mistaken, I told you how to find the centripetal force. If the force is at a certain angle, you have to resolve it, right? Resolve it to the direction of the center. Then you get the centripetal force. So what force contribute to the centripetal force here? The L or the mg? Which force acting towards the center? This is the center of the circle one. This is the center of the circle. Which force? Renal here, Renal? Any idea?
Not so sure, sir.
Not sure. Okay. Anyone? Anyone have an idea? What force do you think act towards the center? It's wrong, never mind. Just give a try, your idea. L is acting diagonally. Yeah. Anyone? Which force do you think act towards the center?
Lifting force.
Yes, the lifting force, right? The lifting force diagonally. So how do you even write here? Do you going to write L or the component? The horizontal component, right, of the lifting force contribute towards the center of the circle, because L can break into vertical and horizontal. The horizontal one is the acting towards the center. So L sine theta or L cos theta mv square over r. Theta is here. When you go down, the theta is increasing. You open the angle. So open use L sine theta. You open the angle, right? Theta when it goes down. When the L you bring down. So this is going to be L sine theta. Okay. So L sine theta equals to mv squared over r. Okay, for this system. First equation. Okay. Any questions, guys? First one. Okay, this is the first equation. Okay, mv squared over r for the first time. We need to resolve the force, and because there is no force perfectly acting towards the center, there is one force acting like diagonally. Just the force should contribute to the centripetal force. Its component, the horizontal component. Okay. Okay. Now we're going to make something new. Another one equation by considering vertically. Vertically, the plane doesn't move up, doesn't move down. Vertically, the force is balanced. Because the plane doesn't move up, doesn't move down. It's just circulating at the constant height from the ground. So force up must be same as force down. Because vertically, the plane doesn't move up or doesn't move down. It's just circulating horizontally. Imagine. Okay, so vertically it's balanced. So what force balanced with what force? What force acting down? Force acting down is mg. What force acting up? What force acting upwards? Which force contribute force upwards, perfectly upwards? Anybody? Give a try. Wrong, never mind. Just give a try your idea. Again, the lifting force, right? The lifting force, right? Lifting force is resolved down, L sine theta. The lifting force is resolved up, will be what? L cos theta. L cos theta is balancing the weight. This is the second equation. Okay, vertically the force is balanced. L cos theta is equals to mg. L sine theta equals to the centripetal force. Okay. Okay, now we're going to do something extra here, which very common they ask in exam. Now they're going to do the first two equation we divide. 1 divide with 2, you get one unique equation. 1 divided with 2. On the left, what do you get? L sine theta divided by L cos theta, you get tangent theta. Right? The L cancel. So yeah, mv squared over r divided by mg, what do you get? You get v squared over rg. Okay, this is the third unique equation for this system. Never happened before. This is the first case where the force is diagonally acting, which contribute to the centripetal force, at the same time balancing the weight vertically. Okay, now we need to analyze this system by using these three equations. These three equations is going to be the determiner to investigate this system. L sine theta is mv squared over r. L cos theta is mg. Tangent theta is v squared over rg. Okay, I give you 1 minute, maybe take down the notes. These notes, I give a free empty space at the side, so you have to write these three equations. The centripetal force is provided by what? The horizontal component, but given by the lift provided by the bank. The lifting force, the horizontal component of the lifting force provided the centripetal force for this system. Okay, physics is understanding. You must have a very good imagination. When I said plane is moving into the page or something, you need to imagine the forces. Okay, like what Einstein says, a good imagination needed to understand the physical world. So try to imagine whenever a system is introduced. Okay, any questions? If you don't have questions, I'm going to ask further more questions about this system. You need to answer me by using these three equations. By looking at these three equations, you need to answer this question. Okay, ready? I ask one question about this plane now. Okay, refer to these three equations. Okay, refer to these three equations. Okay, now tell me, is it possible for the plane? Is it possible for the plane to make the same circular path with the same radius, with the same r, same circular path with the same radius by increasing the tilting angle? Sorry, what I'm doing? Sorry. The question is, the plane want to move in the same circle with the same radius, but with the greater speed. The greater speed. You want to circulate this same circle with a greater speed. Same r, everything same. Just want to move with a greater speed. What will happen to the tilted angle? What will happen to the tilted angle? The tilted angle, the theta in the diagram, will increase, will decrease, or no change when the speed of the plane is increased. Which formula can really tell you the relation between theta and v? When v increase, what happened to theta? Anyone? Anybody? Yes, good, increase. The theta will increase. Based on which equation? 1, 2, 3.
The third one.
Very good, the third one. Okay, the third one. So in exam, if they ask, okay, when v, the question I asked just now, the v increases, what happened to the theta? So how are you going to answer? 2 marks. So you have to say the theta increases, you get 1 mark, but you must give a supporting factor. What is the supporting idea? You must say, you must show this equation. You must say the tangent theta equals to v squared over rg. Therefore, tangent theta is directly proportional to the v squared. So when v increases, theta increases. So
you cannot use the first equation.
Okay, good. Can we use first equation to link the v and theta? Why we can't use the first equation? Because sines, right? Sines y equals to mx plus c. If one is manipulated, x is manipulated, y is responding, right? Other factors must kept constant, right? Okay. So v you manipulate, theta is responding. So the other quantity, is it constant? R constant. Is it L constant? Is it lifting force going to be constant? A plane move faster, what happened to the lifting force? It increases, when the plane move, the thrust, when a plane move forward very fast, the lifting force will increase, will lift more. So the lifting force is actually varying also. So yeah, you change the v, not only theta will change, L also will change. So very difficult for us to link the v and theta here. That's why we can't use the first one, because L is changing. Science means one manipulated, one responding. The other remain constant, right? Then only we can investigate their relationship. So third one, you see, third one is very good. V is changing. We are manipulating the V, theta, we finding what happened to the theta. R and G is constant one. So 3 is the most suitable equation to investigate between the V and the angle. Okay, Riyad, got the idea?
Yeah, thank you.
Okay, so now that's one question. When speed increases, the tilted angle will increase. Okay, now my question, another next question. Okay, again check these three equations. So you have to select one of the equation to investigate this. The next question is, can the theta, the speed is increased, can the theta achieve 90 degrees? Can theta reach 90 degrees? Can the plane tilted until the theta is 90 degrees? Like the plane is like this, the wing is like vertically. And make a circle, theoretically, can it make 90? Okay, so some said yes, some said no. Yes or no? Which equation going to tell that is it yes or no? Which equation is best? 1, 2, 3. The second one, right? Second one. Okay, I don't know whether which equation you choose. Yeah, some of you took the third one too. Okay, because if theta is 90, tangent theta, tangent 90 going to be infinite. It's going to be infinite. So tangent theta is infinite means V have to be infinite to achieve 90. But I tell you, in examination, in the Cambridge examination, the explanation is given based on the second equation, not the second equation. So my advice to you, try to reasoning out this question by using the second equation. Okay, by second equation, L cos theta equals to mg. Okay, if theta is 90, what happened to the cos 90? Cos 90, your trigonometry knowledge, cos 90 is 0, right? So the L cos theta becomes 0. That means what happened? The vertical component of the L becomes 0. So unable to balance the weight at the bottom. Okay. So therefore, not possible. So what's the answer you must say? Based on second equation, L cos theta equals mg, the vertical component of the lifting force becomes 0 when theta becomes 90. Therefore, unable to balance the weight. So not possible. Okay, those who went for the third equation makes sense, but I tell you the truth. In Cambridge, they are, I think, because tangent theta go to infinite, that means V infinite, then tangent become 90. Of course, not possible, but I think more definite answer we can obtain by using the second equation. L cos theta is equal to mg. The vertical component of the lifting force becomes 0 when theta is 90. Therefore, unable to balance the weight. Okay, the vertical component of the lifting force becomes 0 and theta become 90. Therefore, unable to balance the weight, which acting downwards. Therefore, not possible. Vertically, it's not in equilibrium. So the plane, if it make 90, it's going to fall down. The weight going to pull it down. So it can't sustain the circular motion. Once it lifted to 90, it become vertical, like the wing become 90, immediately it will go down because vertically the force not balanced. Okay. Okay, guys, this is the example 4. Tilted system. These three equations you must write on the notes, and the two equation I asked you. Can the when V increases, what happened to the theta? So you explain by using the third equation. Okay. When can it theta become 90? Explain by using the second equation. Okay, so that's what you have to know from this example. Okay, a little unique one, tilted. So what type of force contribute to the centripetal force here? The horizontal component of the lifting force contribute to the centripetal force of this plane. Any questions? Okay, who get the idea? Eh? Okay, no questions. We're going to continue to discuss more examples and more systems. Okay, please take down these three. L sin theta mv square r, L cos theta mg, divide tangent theta equals to v square rg. 2 marks question, they'll ask you to prove, right? Show that tangent theta equals v square rg. So you have to show these two equations first, then you divide, then you show this. 2 marks question. Okay, so let's go to the next one. The next system, planet rotating around the sun, our Earth going around the sun. So because it experiences a circular motion, our Earth has centripetal force. That's its own centripetal force, mv squared over r. Okay, now I want to know what force contributes to the centripetal force of the Earth on the Earth towards the sun. What are the force acting on the Earth? What is the only force acting on the Earth? So, of course, the gravitational force. The gravitational force between sun and Earth is the only force acting on the Earth. Earth pulled by the sun. Okay, the gravitational force. Any other force acting on the Earth? Nothing. Okay, you don't have thrust. You don't have weight. Weight actually, that's Fg is the weight. Okay, don't put down as weight. For the Earth, the gravitational force acting to the side of the sun. This is the weight of the Earth sideways. So the Fg is the centripetal force for Earth. The gravitational force. Fg is what? The gravitational force between the Earth and Sun provides the centripetal force for the Earth to go around the Sun. Okay, not much to talk about here. Okay, this is similar as the first system, like this, very simple system. Only one force acting toward the center is mv squared over r. Okay. Okay. Now this is another complex system, but looks the same as this one. Okay, the vertical circular motion. Okay, so let's investigate. Car moving in a loop. A car move in a loop and come down, like a roller coaster. A roller coaster get into a loop and comes down. Okay, of course, when a roller coaster moves up and down, it experiences a circular motion. So now we're going to investigate 3 locations. When the roller coaster at the bottom at A, okay, and the roller coaster is at the side B, and the roller coaster is on the top, okay, C. Okay, so for the A, B, and C, we want to write what equals to the centripetal force of that system. Okay. Okay, because we've done many examples on the top. Now I want you to be now more like individually try to think how are you going to come up with this equation. First, what do you do when you want to investigate what equals to the centripetal force? Identify what are the forces acting on that system first. Draw a free body diagram. Then whatever force acting towards the center minus whatever force opposing it should be the centripetal force. Okay. Okay, so A, what force acting at A? A roller coaster is at A. So let's say the roller coaster is at A. Let's say maybe you are in the roller coaster. Let's say what are the force acting on you? What force acting on you? Of course, the weight acting down. What else? What force acting up? Anyone? Come on, imagine. Wrong, never mind. Just give a try. Okay, good trying. What force pushing you up? When you press the ground. So what force acting up?
Normal force.
Yes, good. The normal force. The normal force acting up. Okay, thanks. Normal force acting up. Okay, then at the B, the normal force going to act towards the center for sure, and the weight acting down. And the top, both acting downwards. The normal force will act down because you're going to press the track. When you go up, you press the track going to push you down. So you get a normal force. Then, of course, you have the weight also acting down. Okay, this is the free body diagram, roller coaster. Okay, so these are the two forces acting. Of course, you have a thrust and friction. Thrust going forward is 90 degrees to the circle, to the center, so we are not considering it. And friction is backward, also 90 degrees to the center of the circle. It's not going to contribute to the equation. Okay, write the equation now. A, what equals to mv squared over r? So whatever force acting towards the center minus whatever force opposing is mv squared over r. So what's the equation? First one, Fn, force acting towards the center is what? Fn minus weight, right? Fn minus mg is mv squared over r. Okay, simple. B, Fn towards the center, mg is 90 degrees, so mg doesn't involve. So normal force is mv squared over r. And the top, Fn, mg both acting down, so normal plus mg is mv squared over r. These are three equations. Okay, this is similar to the vertical circular motion, similar to the vertical circular motion. Only thing is the tension has been replaced with normal force. That's it. Okay. Okay. So any problem with the equation? Have we got the idea? Okay, now let's further investigate this. This is very useful because I think all of you, you have experience in going a ride with a roller coaster. Okay, so go up and coming down. Okay, very interesting experience. Okay, now we're going to investigate here. Okay, what we're going to investigate is if when an engineer build a roller coaster track like this in a certain radius, let's say you want to launch a roller coaster into this loop. Okay, tell me the roller coaster need to have a certain minimum speed or a maximum speed so that it can make a one full circular path. You need a certain minimum or a maximum. Can you launch at any speed you like the roller coaster? Maximum, is it Vmax? Okay, one of your friends said it's Vmax. Or V minimum.
V minimum.
That means minimum, right? You need to have a V minimum, right? You need to have V minimum because you can't go lower than that. If you go lower than that speed, what happens? You launch it, it can't reach the top. Okay, it can't reach the top. So the same situation, I think I tell you, this is same as the vertical circular motion. Okay, so in exam they'll ask, find the V minimum. Find the V min. Okay, what is the V minimum for this system? A roller coaster which has a loop with the radius of r. Okay, I want to find the V minimum. Okay, so first, which point do you consider? Which is the critical point to get the V minimum? A, bottom, top. Find the V minimum. So consider which point? Consider which one? Consider the top, C. Okay, V minimum, consider the top, because if it can pass the C, the very little speed, but it can pass the C. So the most critical point is the C, the top point. So to find the V minimum, we go to the top. Consider the top. Okay, so this is the first point. Consider the top. So what is the top? What is the equation for C? Fn from top. Fn, this is the formula for the top one. Fn plus mg equals to mv squared over r. Okay, now give a statement. When V is minimum, what becomes zero? What becomes zero? When you go to the V minimum, when you on the top, you are moving with the V minimum speed. What becomes zero? That means you will never fall down. You never fall down. What becomes zero? In this equation, the normal force becomes zero. Okay, the normal force becomes 0. Okay, this is a very important statement. Again, this called weightlessness. You will experience weightlessness. Okay, it's a very good experience. Okay, to explain this further. Okay, let me go to the whiteboard. I'm having a problem with this software. Okay. Okay, let me use this space. Okay. You see, okay, imagine, try to imagine, you are in the roller coaster. Let's say when you're sitting, this is the chair, you are sitting here. Okay. When you go to the top, the roller coaster will be upside down. The chair is upside down. You will be like upside down. Okay. So you are upside down. So remember, of course, on your shoulder, there is a iron bar holding you, iron bar. Okay. So if you circulating, when you go to the top, let's say what's the equation at the top? The normal force plus mg equals to mv squared over r. And this is the equation on top. Okay, let's say you weight your weight around 800 Newton. Let's say your weight is 800 Newton. Let's say your weight is 800 Newton. Let's say you are circulated on top such that your centripetal force, your V is such that your centripetal force is, let's say, 900 Newton. Let's say you are whirled with the speed such that on top you have a centripetal force of 900 Newton. So what will happen to you? The weight contribute the centripetal force. The weight is the one contribute on the top. The weight and normal force contribute to the centripetal force. First, the weight will contribute first. The weight contribute 800 first to the center as a centripetal force. But the centripetal force requirement is 900 Newton, Weight can't afford to give 900. Weight only can give 800 Newton. So what happened? If the force can't afford to give that centripetal force, what will happen to the system? The system tried to go out from the circular motion. You can't sustain the same radius. You have to increase the radius. So what happened? This roller coaster will start to press the track. It will press the track, okay, because you want to go up. So when you start to press the track, what happened? The track going to push you down with the normal force. So the normal force, the track going to supply you another 100 Newton. So you get another 100 Newton from the normal force. So you can sustain the circular path because the normal force together with weight contribute to the centripetal force. Okay. But when do you get the normal force? When you press the track. When you press the track, the normal force will be exerted. But when do you will press the track? Do you going to press the track always? You'll press the track if the weight can't afford to pay can't contribute the centripetal force. Okay. For example, let's say the Fn plus mg equals to mv squared over r. Your weight is 800 Newton, but you move in a centripetal force which is 700 Newton. You just whirl it with the 700 Newton. What will happen? What will happen? Weight is more than the centripetal force. So what will happen? Do you think normal force required here? Here the normal force technically is negative 100 Newton. When you get normal force reading negative, means you never press the track, it fall down. It's already fall down. That means you never stay the circular path. Theoretically, I can say it can't reach the top. Okay, when Fn value is negative means technically we are stating that it never reach the top. Okay, the Fn have to be positive. But what is the lowest Fn you can attain? What is the lowest Fn you can attain so that you still sustain the circular path? Is 0 Newton. And the Fn is 0 Newton. You still in the circular path. Do you pressing the track up? No, you never press the track up because you no need normal force. The normal force is just 0. That means the weight 800 Newton, the centripetal force also 800 Newton. So the normal force becomes 0. When normal force 0, that's the best experience you can ever have experienced in your roller coaster ride. When you go to the top, you never press the seat. You never fall to the bar, iron bar. You are like floating. Okay, you are floating. That moment, that situation called weightlessness, that achieve the speed you are traveling is the minimum speed you are traveling. Okay, when you achieve weightlessness, when the normal force reach 0 to the lowest value. Okay, guys, do you understand the concept I am trying to help you here? Any questions? Okay, go to the top. So we go back. When V is minimum, Fn 0 Newton. Fn 0 Newton. So get into the equation. So Fn is 0 already. So mv squared over r equals to mg. You get the same unique formula. The V minimum is root of rg, as you get for the vertical circular motion earlier. V minimum is root of rg. So when an engineer build a roller coaster with a radius, the speed at the top it should move. The speed it should move at the top must be root of rg. If it's smaller than this speed, the roller coaster going to collapse, going to fall down. Okay. So any questions, guys? So I think time's up. We discuss next class. We discuss in depth again about this with the question. Then another one system. Then we stop. Okay. So if you don't have question, I stop here. Any questions? No questions, Okay. Watch the video back to record down whatever necessary notes. Okay, thanks. See you there.